Okay, testing for symmetry. Example 6, determine what type of symmetry, if any, the graph of the equations exhibit. The first equation is y to the power 3 equal x squared plus 1. Now to test the the symmetry with respect to y-axis, we're going to change x or replace x with negative x. Okay, so in this equation, just take x and put negative x. So this would be y to the power 3 equal negative x all to the power 2 plus 1. Now try to simplify a little bit. So, you know, the square will cancel the negative sign. So we will left with y to the power 3 equal x squared plus 1. Now compare what you get with the original equation. We can see that this one is exactly the same as this one. So yes, this equation is symmetric, or the graph of this equation is symmetric with respect to y. Now to test the symmetry with respect to x-axis, we're going to replace y with negative y. So in this equation, so y to the power 3 would be negative y to the power 3 equal x squared plus 1. Now negative y to the power 3, since the odd power will leave the negative as it is, so we're going to left with negative y to the power 3 equal x squared plus 1. Now this equation is different than the original, so the graph is not symmetric with x-axis. Okay, to test the symmetry with respect to the origin, we're going to replace y with negative y and also x with negative x. So in this equation, this would be negative y to the power 3 equal negative x to the power 2 plus 1. And for y, the negative will remain because the power is odd, while in the x, the negative will be cancelled because the power is even. So again, this one is different than the original equation. So no, this is not symmetric with respect to y. Okay, so as you can see, with respect to the origin. So as you can see here, the only test that produced an equivalent equation is when we replace x with negative x. Here is the answer of this question, as you can see. So when we replace x with negative x, which means that this equation is symmetric with respect to y-axis. Okay, now let's see what about b. Okay, so the same things for b. I will to just test the symmetric with x-axis, I will replace y with negative y, and to test the symmetric with y-axis, I will replace x with negative x. So here in this equation, I will replace x with negative x, and the y will stay as it is. Now this equation is different than this equation, so no, this is not symmetric with y-axis. Okay, now in here I will just exchange y with negative y, so this would be x equal the absolute values of negative y. Now the absolute values of negative y equal the absolute values of y. So I just left with the equation that is equal to the original equation, so yes. But when I test the symmetric with the origin, I will exchange y and x with negative y and negative x. So this would be negative x equal the absolute values of negative y, and this is just like the absolute values, negative x is equal to the absolute values of y, and this does not equal the original. So the only test here is when we replace y with a negative y, which means that the graph is symmetric with respect to x-axis. Okay. Now the same things would be with the last equation. Now when I change x with negative x to test the symmetric with y-axis, the negative will remain because the power is odd. So I will left with this equation, which is different than the original equation, so no. And here I will exchange y with negative y, so this would be negative y equal x to the power 5 plus 2, and this again is different, so no. Now if I exchange x and y with negative x and negative y, I will left with negative y equal negative x to the power 5 plus 2, and the negative here will remain. So I have negative here and negative here, but I don't have negative here. So this is again is not symmetric with the respect to the origin. This is different than the original. So again, no. So none of them is satisfied. So that's why this graph is has no symmetry. Okay. Okay, in example 7, test the equation y equal x to the power 3 for symmetry and then graph it. So the first things we're going to do here is to find the intercept. Okay, and to find intercept, we will set x equal 0 for the y-intercept. Okay, so when x equals 0 in this equation, it means y equals 0. So the point that I have over here is 0 and 0. Now to find out y-intercept, x-intercept, I will set y equals 0. So x to the power 3 equals 0, which means x equals 0. So the point again is the same thing, 0 and 0. So when I find the intercepts, for y-intercept and x-intercepts, I get the same point, which is 0 and 0. Okay. Now to test the symmetry, I will test first the symmetry with respect to y. So I'm going to replace x with negative x. So in my equation, which is y equal x to the power 3, I will change x with negative x, but the power here is odd, so the negative will remain. This is different than this one, so no. Now in the test of the x-axis, I will change y with negative y, so negative y equal x to the power 3. This is again not same as the original, so no. But when I change x and y with negative x and negative y, I have here negative and here negative. It would be something like this. So negative y equal negative x to the power 3. So this negative would cancel with this negative when I just divide by negative. So I will left with this equation, which is same as the original equation. So yes, the graph of this equation is symmetric with respect to the origin. Okay, so now to graph this equation, we need to have couples of the points. So the first points that we already got from the intercepts is 0 and 0. So we can just put this point in our mind, 0 and 0, 0 and 0. And also we can just find another several points of coordinates by just put points of x and then find out the values of y. So let's see, for example, when x equal 1, we can see that y equal x to the power 3, so y equal 1 to the power 3, so y equal 1. So when x equal 1, y equal 1, so the point is 1 and 1. Okay, what about x equal 2? So y equal 2 to the power 3, y equal 8. So y equal 8. 2 and 8 is the other point. You can set also any other point, for example, -1, and when you just substitute these values in the equation, y equal x to the power 3, you will see that y equal -1 also. And again, when x equal -2, you will see that y equal -8. So the point that we have now is 1 and 1, 1 and 1, 2 and 8, 0 and 0, 0 and 0, and -1 and -1, -2 and -8. So the last step is just to plot this point, plot those points. This is the first one, the second one, the third one, and the last two. And we're going to plot them. Then we will connect them. We will connect the points. We will connect the points to get the smooth curve. So just connect this point and you will see that you will have this curve. Okay.